Hello guys, in this video I'm going to be taking you through this question: evaluate the integral of square root of tan x dx. So how do we do it? First of all, we are going to make u equals to the square root of tan x. Of course, when you square both sides, you have u square is equals to tan x, square root of tan x all squared. Then you have u squared is equals to tan x, and then finding the derivative of both sides, will have 2 du is equals to sec square x dx. And of course, from our trigonometry identities, we have sec square x equals to 1 plus tan square x. So we are just going to substitute it here. We'll have 2u du is equals to 1 plus tan square x dx, and then dividing both sides by 1 plus tan square x we're going to have the numerator cancelled by the denominator, so we'll have 2u du divided by 1 plus tan square x equals to dx. Now of course, when we come here, we have u is equals to square root of tan x, so I'm going to, and u square is equals to tan x, so we're going to have the 2u du divided by 1 plus square of tan x. That will give us u to the power of 4 is equals to dx. So I'm going to substitute back here, replacing the integral of square root of tan x dx as with, integral of tan x dx with, of course, square root of tan x is u, so we have u multiplied by 2u du divided by 1 plus, that's 2u du divided by 1 plus u to the power of 4. And of course, when I multiply, I'm going to have integral of 2u squared du divided by u plus u to the power of 4. So I'm going to bring it down here. 2u du squared du divided by 1 plus power of 4. Now dividing all through. Divide all through by u squared. I'm going to have integral of 2u squared divided by u squared divided by 1 divided by u squared plus u to the power of 4 divided by u squared du, which will result to 2 du divided by 1 divided by u squared plus u squared. And of course, this can be integral of 2 du divided by u squared plus 1 divided by u squared. So I'm going to make a reference to expansion of the square of two different terms, so I can make use of that idea. When we have two different terms, a and b squared, of course this implies a plus b multiplying itself, so this will give us a squared plus 2ab plus b squared. And of course, we can have it as a plus b whole squared is equals to a squared plus b squared plus 2ab. And of course, bringing plus 2ab to the other side, you're going to have a plus b whole squared minus 2ab is equals to a squared plus b. And of course, I can have a minus b whole squared plus 2ab still equals to a squared plus b squared. So I'm going to make use of these two ideas here. I'm going to have integral of 1 minus u 1 divided by u du divided by u plus 1 divided by u whole squared minus 2. That's for the first. And then I'm going to have plus the integral of 1 plus 1 divided by u squared du divided by u minus 1 divided by u all squared plus 2. Now, both denominators, they have similarities. When you expand, you still have u squared minus plus 1 divided by u squared. So, and then when you add 1 plus 1 divided by u squared to 1 plus 1 divided by, when you add 1 minus 1 divided by u squared to 1 plus 1 divided by u squared, you have 2. So we can make t equals to 1 plus 1 divided by u. Derivative of both sides, you have the t is equals to 1 minus 1 divided by u squared du. Of course, you find out that this is the numerator of the first integral, for the first integral. So we are going to substitute 1 minus 1 divided by u squared du. We are going to substitute a to it dt. So I'm going to have integral of dt divided by u plus 1 divided by u whole squared is t squared plus, minus 2 plus integral of, now for the second, we are going to make s equals to u minus 1 divided by u. Of course, derivative of both sides, you have the s is equals to 1 plus 1 divided by u squared du, which is the numerator. So we are going to have plus ds divided by s squared plus 2. So we are going to find the derivative of the integral of the t divided by t squared minus 2 and the s divided by s squared plus 2. So I'm going to be integrating them separately. So I'll have, so for the second first, I have the s divided by s squared plus 2. Now, when I make s squared equals to 2 tan square w. You find the square root of both sides. I'll have s is equals to root 2 tan w. And then when you differentiate both sides, you have ds is equals to root 2 sec square w dw. And of course, from here, I can have w is equals to tan inverse of s divided by root 2. So I'm just going to bring all these properties, bring them back here. So I have integral of ds is root 2 sec square w divided by a square is 2 tan square w plus 2. So I'm just going to bring it down here. Integral of root 2 sec square w dw divided by 2 tan square w plus plus 2. Plus 2. Of course, we have 2 here. We can just factorize 2 out. So we'll have root 2 sec square w dw divided by 2 into tan square w plus 1. Of course, we can bring out the constants outside, so we'll have root 2 divided by 2 integral of sec square w dw divided by, recall that tan square w plus 1 can be sec square w, and of course dividing the numerator by denominator, you have, you'll be left with root 2 divided by 2 integral of the w, and then when you integrate the w, you have root 2 divided by 2 w plus c. And from here we have our w as tan inverse of s divided by root 2. So we are going to have root 2 divided by 2 tan inverse of s divided by root 2 plus c. So we've been able to integrate the s divided by s squared plus 2. Now for the second, we have the t, integral of the t divided by t squared minus 2. So the t divided by t squared minus 2. I'm going to make this integral of the t divided by t squared minus square root of 2 squared. And of course, from here I can integrate the t divided by t squared minus root 2 squared by decomposing the fraction first and then solving by integration by partial fraction, or integration of partial fraction. So I'm going to have this as integral of a the t divided by t minus root 2 plus integral of b dt divided by t plus root 2. And of course, I can bring it down to decompose this fraction, t squared minus root 2 squared you have a divided by t minus root 2 plus b divided by t plus root 2. And of course, when I multiply all through by t squared minus root 2 squared, I'm going to have 1 is equals to a into t plus root 2 plus b into t minus root 2. When I expand, I'll have at plus root 2a plus bt minus root 2b. And of course, from here I have to compare coefficients. You don't have coefficient of, you don't have t term on the other side, so I'm going to make a plus b, that's the coefficients of t on the other side, equals to 0. And then for the constants, I'll have root 2a minus root 2b equals to 1. And from equation 1, I'm going to call this equation 1, equation 2. From equation 1, I can have a equals to minus b. From equation 1. Now I'm going to insert it in equation 2. So I'll have root 2 is minus b, so I'll have root 2 into minus b minus root 2b is equals to 1. When I multiply, I'll have minus root 2b minus root 2b is equals to 1. And then when I put the both together, I'll have minus 2 root 2 b is equals to 1, dividing both sides by minus 2 root 2. I'll have b is equals to 1 divided by minus 1 divided by 2 root 2. And remember, our a is equals to minus b. So I'll have a is equals to minus 2 root 2, which will give me 1 divided by 2 root 2. So I'm going to have the integral of the t divided by t squared minus root 2 squared as the integral of 1 divided by 2 root 2 t minus root 2 minus integral of dt divided by 2 root 2 into t plus root 2. And of course, we have constant here, 1 divided by 2 root 2. So we are going to bring it outside. So we'll have 1 divided by 2 root 2 integral of dt divided by t minus root 2 minus, we also have a constant here, 2 root 2 integral of dt divided by t plus root 2. So when you integrate, you have it will result to 1 divided by 2 root 2 ln absolute value t minus root 2 minus 1 divided by 2 root 2 absolute value of t plus root 2 plus c. And of course, from our log reading properties, we can have 1 divided by 2 root 2, and then absolute value of t minus root 2 divided by t plus root 2 plus c. So we've been able to integrate the t divided by t squared minus 2. So I'm going to come back here. So now the integral of the t divided by t squared minus 2 plus integral of the s divided by s squared plus 2. I'm going to have it as 1 divided by 2 root 2, and then t minus root 2 divided by t plus root 2 plus root 2 divided by 2 tan inverse s divided by root 2 plus c. So bringing it down here, I'm going to have integral of the t divided by t squared minus 2 plus integral of the s divided by s squared plus 2 is equals to 1 divided by root 2, 2 root 2, and then absolute value of t minus root 2 divided by t plus root 2 plus root 2 divided by 2 tan inverse of s divided by root 2 plus c. And of course, we have our t here as 1 plus 1 divided by u, and s as 1 minus 1 divided by u. So I'm going to bring it back here. So I'll have 1 divided by 2 root 2, and then absolute value of u plus 1 divided by u minus root 2 divided by u plus 1 divided by u plus root 2 plus root 2 divided by 2 tan inverse u minus 1 divided by u divided by root 2 plus c. And of course, we have our u here as square root of tan x. Square root of tan x. I'm going to substitute for every term of u. I'm going to substitute it with square root of tan x. So I'm going to have 1 divided by 2 root 2, and then absolute value of root tan x plus 1 divided by root tan x minus root 2 divided by root tan x plus 1 divided by root tan x plus root 2 plus root 2 divided by 2 tan inverse of root tan x minus 1 divided by root tan x divided by root 2 plus c. So we've been able to integrate square root of tan x dx. So if you find this video helpful, you can as well like, subscribe, and don't forget to comment on what you've learned in this video. Thank you.